Hey Pre-Calc, we're back for I think part 5 of section 1.4. We are entering into a kind of dicey territory in terms of working through word problems or story problems. So keep in mind, a lot of this is just using this idea that can you solve equations from, like all the equations we've been dealing with so far, can you solve all those if they don't give it to you right away? That you have to do a little extra thinking off to the side. So I'm going to go through as many odds of these as I can stomach, and then I hope you guys can, gain some insight from these problems. So first one we're going to do is number 65. I would literally take notes, by the way, as you're watching these videos, because there's just a lot to it. So I'm going to give myself some work room. Cost of insulation. So it's talking about, the cost of installing insulation in a particular 2-bedroom home is $2,400. All right. The monthly heating costs average $200, but they're saying that the insulation is expected to reduce heating costs by 10%. So the question is, how many months will it take to recover the cost of the insulation? So first of all, I'm going to think about it like this. And I already worked these problems out on my own because I just want to make sure these are done right because they require a lot of thought. So think about it like this. Think about it in terms of savings. I'm paying $200 per month on heating costs. But if I install the installation, I'm going to save $200 times 0.10. So that's what it means to save 10% per month. Per month. So what's 10% of 200? Well, if you remember, multiplying by 0.1, which just means you move the decimal place over 1. So we're saving $20 per month. Now, how much is that in a year? Times 12 months. Whew. See, if you take 20 times 12, you get a $240 savings per year. Now, that's not the question they're asking. The question they're asking is how many months will it take to recover the cost of the insulation? So currently we would save $240 per year on our heating bill if we actually installed the installation. The insulation. It costs $2,400 to install. So how many months? Well, this is how much money you'll get back in a year. So if it costs $2,400 and you divide that by $240, looks like it's going to be 10. 10 something. 10 years? Yeah, but I guess I didn't say how many months it would be. How many months will it take to recover? So it's 120 months. So 10 years times 12 months is 120 total months. So I guess you got to ask yourself about the other variables. Are you going to live in that house for 120 months? What other costs? You know what? I don't have to talk about all that stuff, but other questions kind of pop up when you start to go down that road. All right, number 67 is the next one. All right, so it says Two kids who are 224 meters apart start walking towards each other at the same instant at rates of 1.5 meters per second and 2 meters per second. So you got the visual. How would we determine when they will meet? Let's just say that these are average rates, because not many people walk exactly like a metronome and are constantly at 1.5 meters per second. So if you think about the distance formula, and I don't mean the one with the square roots, I'm talking about sort of the physical science type distance formula. Distance equals rate times time. So it's kind of like we've got the distance that this girl would walk and the distance this boy would walk. So you're going to have a rate 1 times time plus rate 2 times time, which together will equal the 224 meters. All right? The time is the same because it's sort of like taking a stopwatch and saying, all right, they started walking, and then the stopwatch ends once they meet. So rate 1 is 1.5 meters per second. The t is the unknown that we're looking for. The rate 2 is the 2. That's also a t. So it's distance 1 plus distance 2 equals the total distance of 224 meters. And that's a pretty straightforward equation to solve. You combine the like terms and get 3.5t equals 224. And then divide both sides by 3.5. When you do that, you get exactly t equals 64 seconds. So the answer to part A is 64 seconds after they begin walking. So I'll say 64 seconds later. 64 seconds later, they shall meet. Now part B. The question is, how far will each have walked? So together, they will walk 224 meters, but they're each individually walking a different distance. Here's the deal. Distance equals rate times time. So the distance the first person walks is going to be computed. So distance 1 equals 1.5 times the 64 seconds. That will tell us how far this person will have walked. So if you take 1.5 times 64, it's kind of the same as taking 1 times 64 plus half of 64. So it's really 64 plus 32. $96 meters for this person. And then you can just take 224 minus 96 to get the other person, which ends up being 128. So 96 meters here, 128 meters there. All right, I got another distance problem. So we're moving on to problem number 69. Ooh, we got a bullet. A bullet is fired horizontally. Here, I'll just go to the other side of the whiteboard. A bullet is fired horizontally at a target, and the sound of its impact is heard 1.5 seconds later. If the speed of the bullet is 3,300 feet per second, and the speed of sound is 1,100 feet per second, how far away is the target? All right, so here's the question. The distance the bullet travels and the distance sound travels are the two pieces of information that we kind of need to talk about. Here we go. So let's say that the bullet starts here, all right? And the target is right here where this picture is. Picture's unrelated. It's for exercise 68. The distance from the bullet to its target, yeah, is equal to the distance that the sound has to come back. All right? The distance the bullet travels equals the distance that sound travels. That's supposed to be a V. So, distance equals rate times time. So the distance that the bullet traveled is going to be 3,300 feet per second times our first t value. Okay, so we have 2 times at this point. That should equal, so that distance moving forward should equal the speed of sound times our second time value that we're not quite sure of just yet. Here's what we do know. We do know that time 1 plus time 2, together they must be 1.5 seconds. Together they must be 1.5 seconds. Why? Because they're saying 1.5 seconds after the gun is fired, after the bullet starts traveling, so 1 Mississippi and a half, it traveled like that. That was the time that we're talking about. It was the time that the bullet left the gun and the sound came back to the shooter's ear, hearing it. So this can be kind of tricky. Basically what we're saying is the time it takes for the bullet to get to the target plus the time it takes for the sound to get back is 1.5 seconds. So we have a system of equations with 2 variables. 2 equations, 2 variables, means we should be able to solve this thing. So I'm just going to arbitrarily, no real logic here, just say I'm going to get T1 by itself or T2 by itself. Eeny, meeny, miny, T2. So I'm using the substitution method to solve a system of equations, which means I take my first equation, 3,300 now instead of T1, I'm going to plug in 1.5 times T2. You know what? I'm going to use this other side of the board because this is not working out over here. So we have 3,300 times, instead of T1, okay, I'm going to plug in 1.5 times, let's see, yeah, 1.5 times 1.5 minus T2. My apologies. I know it's painful watching videos where the speaker can't speak right. 1.5 minus T2 equals 1,100 T2. Now it's just a game of getting T2 by itself. So I got these numbers already. No need to recalculate. So this will be 4,950 minus 3,300 T2 equals 1,100 T2. Add the 3,300 T2 to both sides. Again, we're just solving an equation. You get 4,950 is equal to 4,400 T2. Get T2 by itself. You divide by 4,400. You get 1.125 or 1 1/8 for time 2. Now, did we answer the question? How far away is the target? Well, here's what we can do. we can now say that the distance that the target is from the shooter is 1100 times the T2 over here. See that 1100 T2? That represents the distance from the shooter to the target. So we just got to multiply that by the 1.125, and you get 1,237.5 feet.